Howdy students, in this video we're going to talk about dilutions, concentration, and we're going to learn an equation called molarity, and then we're going to learn how to calculate a dilution. So dilution has to do with concentration. So concentration is a measure of the amount of solute, which is what gets dissolved, per given amount of solvent, which is what does the dissolving. We measure concentration in what we're going to learn today, which is called molarity. A dilute solution contains a small amount of solute, and a concentrated solution contains a large amount of solute. So if we look at the picture below, on the far left, we have a small amount of solute, and you can see that based on the concentration of the drink, and on the far right, we have more solute dissolved. So the units of concentration are molarity, but molarity can also be an equation, almost like solubility. Molarity is denoted with a capital M, and on top we have moles of solute, and on bottom we have liters of solution. So we have a volume on bottom, and we have moles on top, but the moles is specifically of solute, what gets dissolved. Solution encompasses solute and solvent. So a 1m, which is molarity, contains 1 mole of solute per 1 liter of solution. A 0.5 molar NaCl solution has 0.5 moles in 1 liter of solution. And so what we would do is we could actually figure out how many moles that is and convert to grams. Weigh it out, pour it into a liter of solution, and find a specific concentration. So here's an example involving molarity. What is the concentration in molarity, which is capital M, of a solution made with 1.25 moles of NaOH in 4 liters of solution? So molarity is moles per liter, moles of solute over liters of solution. I would take 1.25 moles of NaOH and divide it by 4.0 liters of solution. When I divide the two, I get 0.3125 m, and I'm going to take two significant figures for 0.31 m. You could also say 0.31 moles per liter. We're going to talk about dilutions next. Dilution is when we dilute something, which means we add more solvent per given amount of solute. So diluting a solution will not change the number of moles. It only changes the concentration by increasing the amount of solvent. So here's our equation. M1 times V1 equals M2 times V2. M is molarity. V is volume. Generally in liters, but you can have either milliliters or liters. This formula works only for dilution. If we ever saw it with stoichiometry, we wouldn't use it for a reaction because we would have to encompass the mole-to-mole ratio. So here's our equation. How would you make 500 milliliters, which is a volume, of 6 molar NaOH from a 12 molar NaOH solution? So I'm needing to make 500 milliliters of a 6 molar solution. So that's one set of variables. And I'm starting out from a solution that has a molarity of 12. So my equation is M1V1 equals M2V2. So I'm going to plug in 12.0 M. My volume is what I'm searching for here, because that's going to tell me how much I need to take in order to dilute, to make less concentrated. The molarity that I want is 6.0 M, and the volume would be 500 milliliters. When I solve for V1, I get 250 milliliters. Now, the question says, how would I make that much? So I'm going to draw a little picture. I have a 12 molar stock solution. What I need to do is take out 250 milliliters, which is what I calculated, and then I'm going to fill the rest up to the 500 milliliter mark with water, or whatever your solvent is. And that will give me a 6 molar solution. Now, in real life, sodium hydroxide is a solid compound. So I can't measure out a volume, so I'll need to convert to grams. So I would take 250 milliliters of NaOH solution, and I'm going to calculate. So I'm going to go ahead and convert 1,000 milliliters to 1 liter. And I can actually use molarity as a conversion factor. So 12 moles per 1 liter. And that allows me to convert moles into grams using molar mass. And the molar mass for every 1 mole of NaOH, I have 40.0 grams of NaOH. And when I calculate, I get an answer of 120 grams of NaOH. And this actually allows me to weigh out on a scale how much I need in order to create the solution. And we're going to do one more example to finish out here. For a lab, we need 500 milliliters of a 4.25 molar solution of HCl. Concentrated HCl is 12 molar. How do we make up the solution? M1V1 equals M2V2. 12.0 M is my concentrated. V2 is what I'm looking for. The concentration I need is 4.25 M. And we need a 500 milliliter volume. When I solve V2, this should be V1. I get an answer of 177 milliliters. So once again, if I draw a picture, I've got plenty of stock solution, which is 12 molar. I'm going to have to take out 177 milliliters and I'm going to have to mix it all the way up to, with water, to the 500 milliliter marker. And when I mix that, I'm going to get a molarity of 4.25.